So hello everyone, this is Easy Automation here, and in this video we are going to talk about the timers in Allen Bradley. But before that you need to subscribe our channel because we want to build this community around PLC automation. So hit that subscribe button and jump into this video. So the question is, what is timer? The timer is the instruction which gives the delay between input and output. So for explaining the timer, I have one example here of a electric oven in which you cook the food for certain time. So you put your food in the oven and you set the timer and you click on the start button, and then it will start counting for that time, and as soon as the timer reaches its limit, the oven will start sounding the alarm. So the software which is counting this timing is the timer inside the processor of that oven. So I hope you got the point. So now we will talk about the timers in Allen Bradley. So there are two types of timers in Allen Bradley. One is retentive type and another one is non-retentive type. And in retentive type, there is one timer, that is RTO, which is retentive on delay timer. And in non-retentive type, there are two types. One is T on and another one is T off. T on is for on delay timer and T off is for off delay timing. But before starting to explain these timers, you need to clear some concept about the timers. So every timer has three bits inside it. One is timer enable bit, another one is timer done bit, and third one is timer timing bit. And the timer enable bit will only energize whenever the timer is getting supply, and the timer done bit will work differently for different type of timers, so about which we will talk further in this video. And the timer timing bit is the main bit in this whole timer instruction. So to show the timer is counting, we need to use the timer timing bit. So these are some bits you need to remember before using any timer. So now let's start to know how to use these timers. So you need to go here for this timer and counters and drag one timer here in our first run, and as soon as you drag one timer here, you will notice some titles on the timer instruction. The first one is timer, which is just basically the name of this timer. For that you need to put T4 colon 0. The T4 is the timer name and the 0 is timer number. And if you use multiple timers in a program, you will just put that number here instead of 0. And the next is time base, which is just a multiplying factor to get the delay. And if you click on this time base, you will find three types of time bases here, about which we will talk in our further videos. And next is preset value, for which the timer is going to count. And the last title is the accumulator. And the accumulator will show the exact time on which the timer is running on that same instance whenever you open the program. So these are some of the titles you need to know about the timer instruction and the bits which I have talked about. So now let's give the preset value of 10 seconds. So to get the actual delay, you need to multiply the time base with our preset value. And whenever you do that, you will find the time delay for which our timer is going to count. And to give supply to this timer instruction, we need to add one NO contact here, and I will just give name as start. And here you will notice that we have only enable bit and done bit here, but we need one timer timing bit. So for that, we need to add one rung here and one NO contact here, and we need to name this as T4 colon 0 slash TT. This TT means the timer timing bit. And now this TT bit belongs to timer 0, and whenever it gets high, our output should go on. So I will just use one output coil here. I will name it as bulb. So whenever our timer is counting, the bulb will go on, and whenever the timer is done with its time, it will just turn off that bulb. Let's go download. So if I toggle this NO contact on, then our timer will start here, and as you can see here, our accumulator is accumulating the time and our enable bit is high here, and as soon as the timer preset value and accumulator value are going to be equal, then our done bit will start here, and our timer timing bit was only on for these 10 seconds. So now you know how to use this timer. So now I will just use one another bulb to show the timer done bit. So for that we need one another rung here, and we need to add one contact here and one output coil here. And for that output coil I will just give the name. So I will just name it as bulb 2, and for this contact I will just give address of T4 colon 0 slash TN. So now whenever the done bit gets activated, then our bulb 2 will start here. So let's see how it works. So we have used timer timing bit here, timer done bit here. So whenever I give supply to our timer, the timer timing bit will start and enable bit will also start. But this done bit will only start whenever the timer accumulator and timer preset value gets equal. So let's start this timer. So I have started this timer and it started counting, and our timer timing bit and enable bit are on. And as soon as it reaches 10 seconds, the done bit will turn on our second bulb. So this was the whole idea behind the T on timer. So I hope you got the T on timer. So now I will just show you how you can use the T off timer. So I will just delete this T on timer and I will just add one T off timer from this timer and counter instructions. So this is the T off timer and the titles are same as the T on timer. So I will just give the address T4 colon 0 and I will just keep the time base same as the T on timer like 0.1, and I will just add a preset value of 10 second, and the accumulator will accumulate the 10 seconds same as the T on timer. But till here the T off timer is same as of our T on timer, but the difference will happen whenever we give the supply to our T off timer. So let's check how this works. Program is in running condition. So to show the difference, I will just toggle this input, and our timer is not started yet because this timer is T off timer, which works whenever the input goes off. So if I turn off this input, the timer will start counting for 10 seconds, and our done bit is on as soon as I given the supply to our timer, and the timer enable bit is also turned on because I have given supply to our timer. So I will just remove the supply and our timer will start counting, and our done bit and our timer timing bit will go on here, and as the timer reaches its limit, the done bit and timer timing bit will go off. So this was the whole difference between the T on timer and T off timer, and this T off timer is used where our process is working after completion of our previous process. So if our previous process is done, then our timer will start counting for our current process. So this was the operation of T off timer. Now let's talk about the RTO, which is retentive on delay timer. So I will just delete this T off and I will just drag one RTO here, and as you can see the titles are same as of that T on and T off. So I will just give the address T4 colon 0 enter, and I will just keep the time base 1.0, and I will just give the 20-second delay in our preset value, and this accumulator will accumulate same as our previous timers. But the main difference between RTO and T on and T off is this timer will retain the time even if we cut the supply off. So for comparison, we will just add one T on timer here. So to compare this RTO with our T on timer, we need to add one rung here, and I will just copy this contact for second rung as well, and I will add one T on timer here, and I will name it as T4 colon 1 and keep the time base as it is, and I will just give the delay of 20 seconds. So now we can compare RTO with our T on. So here what will happen is, if I give the supply to our both timers with same start button, the RTO will start counting the time and T on will also start counting the time. But the difference happens whenever I turn off this input for our timer. So to see that, we need to put this program on run mode. So I will just run this program. So our program is in running condition where I will just toggle this start input, and our timers have started counting for the time delay, and the difference which I am talking about will happen here after I untoggle this bit. So now you can see our T on has resetted its accumulator, but our RTO has retained its accumulator value as it is, where I have cut the supply of RTO. So I will just give that supply again, and our RTO will start counting where it has stopped. Like in our case, it has stopped on 15 seconds, so it will start counting from those 15 seconds to 20 seconds. And as soon as it reaches the 20 seconds, the done bit will energize and timer timing bit will go off. So this RTO will work same as the T-on instruction, but the only difference is this retains its accumulator value and T-on timer is not able to retain its accumulator value whenever we cut its supply off. So this was the whole difference between RTO and T-on. But now the question is how to reset this RTO. So for that we need one instruction here. So I will just go offline. So I will just delete this T on run because now we know the difference. So to reset this accumulator value of RTO, we need to add one rung here in which we need to use one reset coil, and for that we need to give T4:0 address. And now this reset coil will reset this timer whenever we give supply to this reset coil. So we need to add one contact here, and I will just give address as reset. So I have named this contact as reset, and this reset coil will reset our RTO. So let's see how it works. So now if I give supply to our RTO will start counting for the time delay I have put here. And if I turn off this input, our timer will retain its accumulator value. But I want to reset this timer, so I will just toggle this bit of reset. Then you can see our accumulator has gone to 0. And if I untoggle this one, our timer has gone to its initial condition where its accumulator was 0. So if I want to turn that timer on, I will just toggle this bit again. Then also our timer will start counting for its timing. Like here it will just count for 20 seconds and then our done bit will go on. And to reset this timer we need to but before that we need to turn this off, and then you need to reset the timer and our accumulator will go to 0. So this was the whole idea behind the RTO timer, and the industrial application of this RTO is to count the actual process timing. Like take one example of a motor which is going to operate for 20 seconds, and if our motor is on, then the start will go on and our timer will count that timing for which our motor is on. And if the motor goes off, the timer will save its timing to its accumulator, and whenever the motor will go on again, the timer will start counting, and if the motor goes off again, the timer will save that timing where the motor has gone off, and whenever the motor goes on again, it will just start counting from where it gone off. So this RTO will give us the exact timing for which our motor was on. So this was the simple application of RTO. And if you have any other application where you can use the T on, T off and RTO, you can easily comment that application in our comment section. So I hope you got the point of T on, T off and RTO. And if you have any queries in your mind, you need to put that thought in our comment section. I will always be there to answer your questions. And if you learned something new, go hit that like button and subscribe our channel if you haven't subscribed yet, and share this video to your friends and colleagues who are interested in factory automation and PLC automation. So with that being said, I will see you in the next video. Till then, keep exploring my previous videos because we want to build our community. Bye.